Hello. I'm excited that we're back from lunch now, and I'm even more excited now that I've learned that we have lightning talks to look forward to on Friday. But for the next 40 minutes, we'll be talking about a programming language for continuous delivery. And we're actually going to do 3 different things. My favorite thing about going to conferences, especially single-track conferences, is sitting in the back and having a chance to step back from what I'm doing day to day and think about how I really want to be working. So we're going to spend some time reflecting on what programming is like for us today, together. Then we're going to spend some time thinking about how we got here, which seems to be the entire topic of this day, so some similar themes coming back. And then finally, we'll look at where we might be going in the future. So, the beginning. What do you love about programming? I'm going to give you about 30 seconds, which is a long time to stare at a silent crowd when you're on a stage, to consider this for yourself. It might be the thing that got you back after lunch sitting in a chair to talk about programming. It might be how you got into it to begin with. It might be the really fun thing that you worked on last week. I'm going to think you've probably come up with one by now. So for me, it's the ability to make things that didn't exist in the world before. So that might be something that has a physical hardware component. It might be something really silly that I did for fun that has no utility whatsoever. It might be something for an actual job or a side project that I maintain over time. But the moment where I've gone from something not existing in the world, having an idea, and then having it be real and other people use it, something that matters a lot to me. Let's think about the flip side. This is an extreme word, but what do you hate about programming? What's the thing you will try to avoid when it comes up at your workplace? What's the thing that last week made you want to slam your head into the desk or throw your laptop at the wall? I know it happens to all of us, no matter how much we like our jobs. For me, it's syntax errors, whether it's spending 4 hours hunting down a missing semicolon, or more recently, where's the bug in this sentence? You are not laughing, so I'm hoping maybe you haven't encountered this before and I can save you from 8 hours of misery. There's this huge difference between smart quotes and normal quotes, and depending on your text editor, they might look exactly the same or exactly different. And so pretty recently, I was adding a new job description to our website. I wrote it in a Google document because I wanted people to be able to read it who weren't in our GitHub repo and reading Markdown. And then when I was happy with it, I copy-pasted all of my text over very carefully. Static site doesn't work anymore. I look at the little header things at the top, and I'm like, did I change something? I go check if anyone else has made changes while I was writing this. I spent a long time trying to figure it out. I'm embarrassed that I can't figure it out, and then eventually ask someone else on our team. Ian spends another couple hours on it, and then figures out it's the smart quote problem. The worst part about this is when I showed this slide to our team, someone else tried to take credit for finding this bug because it's happened to me more than once. So I hope you remember that, if nothing else, from this talk. But it's easy to go through and pull out things that we think are great about programming and things that are not so great about programming. But what I want to do is think about that more in context, in the end-to-end of building one application. And so I'm going to give you a little bit of context for this story so it'll make more sense. I'm an introvert, and my favorite thing to do is to read a book, maybe with a cup of coffee, maybe with a cat, but most importantly, not with other people. And I enjoy coming and talking to all of you about what we're doing. That's really fun. But after 3 days of this, I will probably not be very fun anymore. And I have a hard time holding myself accountable to this. And so, like any good developer, I took a very human, personal problem and thought, I will make software to solve this. And so I decided all I needed was a little bit more accountability. I was going to make myself an application that served as a battery that was a reflection of my personal energy level. If I'd been alone for a while, full battery, great, do whatever you want. If I'd been at a conference for 4 days, not so full battery, go home, be by yourself until other people will like you again. And I thought, this will be super easy. My expectation getting started with this is I'm just going to send myself a text message every day. It'll ask me if I'm feeling better or worse, and then it will move the level of my battery up or down accordingly. Like, sure, there's some logic of it can't be more than full and it can't be less than 0, but pretty easy. I thought I would sit down and 2 hours later, I would have a working application that I could use, and so could others. I'm a little optimistic, but I found this to be also true of many people I've worked with. In reality, 3 months later, and I was doing this on my nights and weekends, so this wasn't 3 continuous months of work, I'd set up Rails and I'd set up Heroku and I had added a gem just to be able to have some auth, and I'd spent a lot of time checking dependencies and versions across tools. When I got to the part where I was going to write the actual logic for the application for the battery incrementing and decrementing, and to send myself some text messages with Twilio, I had to make changes across 12 files, which seemed like an awful lot for 2 very simple things. And at this point, I didn't have any callback logic, I didn't have any error logic. I didn't really get it to the point where anyone else could use it. And this was particularly disappointing when my friend Kelsey commented on my GitHub repo a year later to say, ooh, I'm going more conferences now. I want to use your application to hold myself accountable. I had to go, I haven't touched it, and it works for me, but I don't know how to get it up and going for you. So how did we end up in this somewhat strange world where I'm sitting around thinking about how many nodes my clusters need for my weird side project that no one else uses? This isn't really what we want. I don't think it's what anyone here wants, unless you're the person whose favorite thing is doing that. And so I think it actually is a pretty philosophical concept. The first tenet of the UNIX philosophy was to make each program do one thing well. To do a new job, build it fresh, rather than complicate old programs by adding new features. And this makes a lot of sense and works for us sometimes. So Docker is a great example. It made virtualization a lot easier. It made it much easier to manage our environments between dev and production. And we had that. And they're like, oh, great, we have this now. Let's add compose and swarm. And then we went to Kubernetes, and then we were writing a bunch of YAML, and then we decided to add a bunch more stuff, and now we have service meshes and API gateways. And so every time we build something pretty good, we build something else on top of it. And this is how we've always done it. It comes a little bit from our perspectives of wanting to solve our own problems, but I also think it comes from this philosophy. And we keep doing it to the point where this is the diagram the CNCF releases about an introduction to the cloud-native ecosystem. And my favorite thing about it is it has a little note that says, are you feeling overwhelmed at the top? Which I can't actually read what any of those products are, so yes. And I'm not really sure how I would spend my time figuring out what all 400 of them do. And so then they have a link to a simplified version of the diagram for the rest of us. And most of the time in your day job, you probably don't need to think about the 400 things that are here. But you might start a new job and ask someone how deployment works at the company. What happens from the time I write something in my editor until it's actually deployed to users? And someone might do a really nice job of walking you through a bunch of steps that look kind of like this. And the thing that really bothers me about this is most of the things I just showed you aren't about delivering value to the end user. For me, that was just, I want to send my text messages and have my battery update. They're things that are accidental complexity. If you haven't run across this before, this essay was already referenced once earlier today. Fred Brooks wrote an essay, No versus Silver Bullet, applying this framework to software. All software construction involves essential tasks, the fashioning of the complex conceptual structures that compose the abstract software entity, and accidental tasks, the representation of these abstract entities in programming languages, and the mapping of these onto machine languages within space and speed constraints. I have a hard time reading it in addition to parsing it, so the simplified version and how I tend to think about it is the stuff you want to do compared to the stuff you have to do because of how computers work. And so the funny part about this is when Fred Brooks wrote this essay in 1986, the whole point he was making was that there wasn't something that was going to make it radically easier for us to build software, because almost everything we did was required and essential. He thought there wasn't very much accidental complexity. I can tell you for sure he never saw that chart that we were looking at when he was saying that. And so today, when you look at that system, or when you think about the average project and what it goes through to get to a point where we can ship, I feel like there's accidental complexity everywhere when we're thinking about infrastructure, deployment, monitoring, security, dev production parity, pretty much everything we do, all the way back to stuff that Fred Brooks was talking about, like syntax errors. And this is a huge problem for 2 reasons. One of these came up earlier today, which is this doesn't let people really get involved in our industry very easily, or even once you start figuring out how to use one tool and get one thing working, it's hard to figure out where to go from there. We're locking people out with the amount of complexity that we have. And the second part is, even if you know how to use a lot of tools and do many of these things, I don't know about you, but I don't really want to set up a CI pipeline again. Like, we did that at my last job. We don't need to do it again at every single job. We're doing the same thing over and over again. But it seems a little bleak. What are we going to do now? The tool that we had before, which was coming up with a problem and then building one more thing to give us a solution to that problem, hasn't been working. That's what got us here. I think instead, what we can do is, what happens if we start to take things away? 3 of the things that I felt when I started looking at these systems and writing all these applications and going, where am I spending my time, that added a ton of complication were getting infrastructure set up, getting a deployment pipeline set up, and then writing a bunch of logic around talking to other people's APIs. And so we started to look at what would happen if you didn't do those, and what would you need to take away to be able to do that? And like we've talked about a few times today, if you take away all of that, you're kind of back in the web development of the 1990s, where you can just build stuff and it just works. So this was the original mission for Dark. How can we build an environment so people can code without any of this accidental complexity? And the way we wanted to solve that was by looking at putting together something that was holistic, putting together the programming language, the editor, and the infrastructure, and seeing what we gained by taking out the intersections between this tooling. So now's the point where I re-caveat. I'm going to demo for you. This is an alpha, so please don't take photos. Please don't share it. The reason I'm demoing for you is it's one thing to stand up on stage and say, everything would be better if we can do this. And it's another thing to stand on stage and build a working application within your allotted time in about 10 minutes. So I want to show you that we can do that. And of course, I think this is the right answer, or at least part of it, because I've been working on it for so long. But I hope you spend at least as much time looking at the individual concepts and how they might play out in your environment and your work, rather than just thinking of it as a monolithic solution. So let's do this. Before we do, since I just told you everything was going to be completely different, and whenever you tell someone you're going to show them a programming language, they start to be like, is it like Haskell? Is it like Rust? What's it like? The least interesting thing about Dark is the language. And so I'll just show you that to get it out of the way. This is FizzBuzz, written in Dark. I'm sorry for forcing you to look at FizzBuzz again, but it's an example that many people have seen sometime over the last 10 years. And it looks a lot like code. So now that hopefully you believe me this is going to look a lot like code, let's go through building something. Cool. OK. So first thing about Dark. Hopefully you will be able to see this, and it will be large enough. Everything is entirely in the browser. I only did one thing before coming on stage, and this is honestly just for my ease of use. I made a bunch of functions that have strings that have my credentials for talking to other APIs. So first thing you do with any new programming language, you make a hello world. In this case, we're going to make an API endpoint that returns hello world. We're going to specify that the method is a get. We're going to write hello world, and we're going to open that. Open a new tab, hello world. OK. So when your internet works to begin with, that's a lot more exciting, because you go from 0 to hello world in about 10 seconds, which if you're me otherwise, you spend like 2 hours trying to figure out how Rails works again and then setting up Heroku. So the cool thing about this is a bunch of other stuff works out of the box too. So if we change this to have a URL parameter and say we want to greet our guests by name, we can do hello, and then we have this variable available to us. We need a space. And when we go back over here, we can say hello to me, which seems a little silly because I'm here. We can also say hello to Sarah, who is a good MC. We can say hello to Barcelona. And you can see everything's still working. We have a JSON API. When we go back to Dark, each of these dots on the left-hand side is one of those incoming requests. So you can see here the parameter name is Ellen. You can say here it's Sarah. You can see here it's Barcelona. And if we want to make a change, say change our greeting to hi, we get in real-time evaluation of that former trace for what that would do if we re-executed the code now. So if we change it to hi, it would be hi, Sarah. And so we're able to go through with any given trace. OK, so that's a hello world with some URL parameters. But what if we want to build a full application? To save us the effort of uploading a bunch of assets over Vodafone, we're going to go here, where I have pre-uploaded to our CDN. So to show you what that is, Dark is only for building back-end web services. And so you can build your front end in your favorite flavor of JavaScript. You can actually host your front end wherever you want to. But in this case, what I'm going to do is I'm going to use the one that we already have up and hosted in Dark. All I did to make this JavaScript app work with Dark was I pointed my API host at the API that we're using. In case you're interested, the way you upload to the CDN, we have this one command line tool. I built this in advance because building takes too long. You can see it's just npm run build up here. And then we have a command line tool that I used earlier. You can see I've made 2 backups just in case. That just takes the parameters of what canvas are you uploading to, what's your user, and where's your build file. And so what that looks like, we're going to hide that. I'm going to make a new handler, and I'm going to serve our assets. And much like before, we didn't deploy. And here we have a React application. In this case, what we're going to build end-to-end is one for signing in to visit me at the Dark office. So we'll have a list of people who work at Dark and how to contact them, and then we'll let visitors post that they are there, and then we'll send notifications to me both via text message and Slack DM. So first things first, we're currently getting a 404. Normally, I think many of you would do this. We would inspect and go try to figure out what's going on over here. Instead, in Dark, we get that information from our sidebar, and our endpoint can be configured for us. So first things first, let's just try it out. We'll do me, and we'll do my co-founder. Go back to our React app. No 404, real data. Of course, real application, don't want to just be returning a list of names. Let's make a new data store. And we're going to have hosts who have names, and they're going to have phone numbers, and they're going to have Slack IDs. And we need to put someone in here. And so in Dark, one of the concepts we care a lot about is being able to build tooling side by side with your application. And so we call them REPLs. They're not true REPLs, but I'm just going to make one. And basically what it does is it lets you interact with everything else in your application. So what I want to do is I want to add myself to this data store of hosts. So my name is Ellen. My phone number, we're going to just call the Ellen phone function rather than tell you. And my Slack ID, we're going to go grab from Slack. This is very helpful if you're doing Slack integrations, by the way. If you need a more robust channel, you have to go get it. But if you're doing this, you can just get it here. And since our data store is key value based, what I want to do is extract this into a variable so I can reuse it. We'll name it Slack ID, and you can see it's dynamically renaming itself in the other use. Here. And hosts. And so I showed you before that we were able to see the output of the hello name just by looking at the expression. Since our data store functions have side effects, you can choose to run the expression. And so when I do this, I'll see the output. Please work. Thank you, Internet. There we go. And you can see now this is the record that we inserted. And we can also see this, that we're calling the Ellen's phone function and this preview of schema. And if you look at our data store, you get the reverse, the REPL's calling it. And you can see that it's also locked because we have production data in it. So we don't want to edit our schema anymore. Let's go back and edit this. And we don't need all of that other information about me, so we're just going to map to get only the names. So this should work now. When we head back over, what we're expecting is to see only me, since that's the only person we've inserted into our database. And there we go. All right, so you're a full stack fest attendee who is visiting me for some reason. When you sign in, probably going to guess, very similar workflow. We need to make an endpoint to handle our visits. The cool thing about this endpoint is compared to the other one is when we look at our requests now, we also see all of the information coming from our form body. And we can work with this as we do it. So very similar, if we decide to put this into a data store, we can work with request.body, see what that looks like, and then set up a data store that has the same schema. I'm actually very impressed with Vodafone. And this time, we don't have a unique identifier, so I'm just going to generate one, visits data store. It's the same thing, things that have side effects you choose to run. I'm going to generate a key. Yep, looks like a key for a data store, and insert into our data store again. Cool. So now if we go back and do this, it's going to work. I'm not going to get a failure, but I'm also not going to know that you're here to visit me. So let's set up a couple background workers to talk to Twilio and Slack to send me those notifications. So first one, I'm going to emit. If you're not, it's an eventing system, so I'm emitting a specific event. In this case, the same one that we were already working with. And I'm going to do it to send a text. And then I'm going to make basically the same thing, except to send a DM. And so when I play each of these, everything about events and background workers works very similarly to how our REST requests work. And so when we go over here, I'm going to refresh. Thank you, Vodafone. Those will hopefully appear. In the meantime, I will make them dynamically. So I'm going to make a new worker called sendText. And so you can see here, we don't have an event yet. Let's try this again. Yep. And so now we have an event that will come up where we can see we both have host and visitor. And so let's pull this out and then grab the rest of my information from my data store, hosts, and then grab my phone number. And so one of the things I'm doing is instead of like writing a bunch of code and then going back and debugging, I'm relying really heavily on having my information from my trace. And so when I query from my data store, I can see that it works. I can check that I'm getting a phone number that's formatted the way I want back. Now that we want to actually send the text message using Twilio, Twilio is set up in Dark, so you can call it the same way you would call a language function. So if I just type Twilio, I get my creds that I stored before, but I also get this function. And it gives me the 5 parameters that I'm going to need to be able to integrate with the API, which is my SID, my token, my from number, and then we're sending the text to my host, and let's tell them that the visitor is here to see them. You can see, again, I'm getting these references on the side of everything I'm using. Nope. It's amazing how much more difficult typing is while people are watching you. And so the cool thing is, same as we had from the expressions that are native to the language, we can also choose to execute this. And so when we try, it's going to execute on the event we're on, so full stack vest attendee as the visitor. And we get a response. We get the body back. We get the message that someone's here to see me. And we actually get the text message live. It's really nice. So if the text message wasn't here, I would rely on the live value. In this case, apparently T-Mobile is working better for me than the Wi-Fi, so that works. Same thing. Let's do it for sending a Slack DM. We're going to write a lot of similar logic here. So we know the host name is event.host, and then we're going to, sorry, the magic butterfly keys, my E key doesn't work very well. And copy paste works very well by expression, so I'm just going to copy over. And then grab, it's going to be the channel. Cool. And so again, relying on this, make sure it works. Works. Cool. So with Slack, we haven't rewrapped the API yet. So what we're going to do instead is we're going to use the HTTP client library. And first thing we're going to do actually is we're going to need a header. So let's build that out. And I want to specify my content type. So let's do that. And now you can see, again, I'm really fond of this. You can now tell what my header looks like from what my authorization is all the way through the fact that I've passed in the right car set that I want. So now let's actually make the call. So Slack API, this I have just memorized, although it's pretty intuitive. And then for the body, we're going to send the token again. And we're going to send the channel, this channel. Then we're going to send text, which is event.visitor, same thing. Cool. And then we don't need a query, so I'll just make an empty object, and we already made our header. So same thing, let's try it again. We get the Slack message before we even get the confirmation back in the browser. So now what we should have is an application that is working end-to-end and will send me Slacks and text messages. So let's give it a final go. Well, we get the confirmation, we get the Slack, and hopefully someday, yep, get a text message. So back over to slides. So there you go. You got to see what we did. But I also want to touch on a little bit of one of the things that's like an elephant in the room. Like, I didn't show you how collaboration works. I didn't show you how version control works. I didn't show you how feature flags work. There's only so much time we have, so get something working, and then we can do cool stuff later. But it definitely seems a little weird to have all these like little square windows of code flying around, and that was why I showed you the code at the beginning. The point of that is what we're really moving towards is the fact that when you start a new job, you don't go to someone and say, how does our file structure work? You go to a whiteboard, and they draw you an architectural view. And one of the things you get out of having a holistic system where you can see the code, you can see the traffic, you know what the data stores are, is you can actually visualize that. And so what we're going for is something more like this, and all of the floating code windows are something that's on the way to being able to show people a lot more introspection about their application as they're operating it. The other thing I want to call out is this is like actually real. All you have to do is if you go to ln-fullstackfestbackup.builtwithdark.com, that'll work, and you can put anything in that visitor box, and it will actually send me a text message and a Slack DM. If you want to do that, if you put your email address in, I'm happy to email you after with more details, or so you can ask me questions, or however it is. But in order to get to this working web application, we didn't spend any time setting up our environment. We didn't spend any time thinking about our deployment pipeline. It just worked for us out of the box. We didn't spend any time thinking about our infrastructure. We just specified schemas, and then we had data stores that worked for us. We didn't think about additional API logic. There's a whole lot of stuff we didn't do that let us build this in 10 minutes. Of course, we did spend a little time getting Wi-Fi to work, but I'm pretty sure I'll take that trade-off since there's reliable Wi-Fi at my house and office. So yeah, this is what I hope our future looks more like. Rather than thinking about, rather than thinking about this, I hope that we have infrastructure that just works for us as soon as we write reliable backend code. I hope that we don't have to think about deploying. The same as we have serverless, which, as we know, means we still have servers. We still have deploys in Dark. We just don't have to think about them as we're developing. And I hope that rather than spending a ton of time on API logic, we can think about them more like how we think about functions. But really, what I hope you think about is next time you're trying to think about how can I spend more time on the parts of programming I love, or less time on the things I hate, or just how can I get this done? Instead of thinking, what can I add? Think about, what can I take away? This might lead you down a 2-year journey to build a programming language so you can build an introvert battery meter in 10 minutes, but it might lead you somewhere completely different, and I highly advise that it's pretty interesting. So thank you.